We are finally ready for an in-depth discussion of grouping and aggregations in SQL. And why is this important? Well, as you can see, I have asked ChatGPT to show me some typical business questions that can be answered by data aggregation. So let's see what we have here. What's the total revenue by quarter? How many units did each product sell last month? What is the average customer spend per transaction? Which region has the highest number of sales? Now, as you can see, these are some of the most common and fundamental business questions that you would be asking when you do analytics. And this is why grouping and aggregation are so important when we talk about SQL. Now let's open our data once again in the spreadsheet and see what we might achieve through aggregation. So I have copied here 4 columns from my characters table: guild, class, level, and experience. And I'm going to be asking a few questions. The first question, which you can see here, is what are the level measures by class? So what does this mean? Well, earlier in the course, we looked at aggregations. And we call them simple aggregations because we were running them over the whole table. So you might remember that if I select the values for level here, I will get a few different aggregations in the lower right of my screen. So what you can see here is that I have a count of 15, which means that there are 15 rows for level, and that the maximum level is 40, the minimum is 11, and then I have an average level of 21.3 more or less, and if you sum all the levels you get 319. So this is already some useful information. But now I would like to take it a step further, and I would like to know these aggregate values within each class. So for example, what is the maximum level for warriors? And what is the maximum level for hobbits? Are they different? How do they compare? This is where aggregation comes into play. So let us do just that now. Let us find the maximum level within each class. And let us see how we might achieve this. Now, to make things quicker, I'm going to sort the data to fit my purpose. So I will select the range over here and then go to data, sort range, and then in the advanced options, I will say that I want to sort by column B because that's my class. And now, as you can see, the data is ordered by class, and I can see the different values for each class. Next, I will take all the different values for class and separate them, just like this. So first I have archer, then I have hobbit, then I have mage, and finally I have warrior. So here they are, they're all have their own spot right now. Finally, I just need to compress each of these ranges so that each of them covers only one row. So for archer, I will take the value of the class archer, and then I will have to compress these numbers to a single number. And to do that, I will use the max function. This is the aggregation function that we are using. And quite intuitively, this function will look at the list of values, will pick the biggest one, and it will reduce everything to the biggest value. And you can also see it here in this tooltip over here. Doing the same for hobbit, compress all of the values to a single value, and then compress all of the numbers to a single number by applying an aggregation function. So I've gone ahead and done the same for mage and warrior. And all that's left to do is to take this and bring all these rows together. And this is my result. This is doing what I have asked for. I was looking to find the maximum level within each class. So I have taken all the unique values of class and then all the values of level within each class. I have compressed them to a single number by taking the maximum. And so here I have a nice summary which shows me what the maximum level is for each class. And I can see that mages are much more powerful than everyone and that hobbits are much more weaker according to this measure. I've learned something new about my data. Now, crucially, and this is very important, in my results, I have class, which is a grouping field, and then level, which is an aggregate field. Okay, so what exactly do I mean by this? Now, class is a grouping field because it divides my data in several groups. So based on the value of class, I have divided my data as you see here. So Archer has 3 values, Hobbit has 4 values, and so on. Level is an aggregate field because it was obtained by taking a list of several values. So here we have 3, here we have 4, and in the wild we could have 1,000 or 100,000 or millions. It doesn't matter. It's a list of multiple values. And then I've taken these values and compressed them down to one value. I have aggregated them down to one value. And this is why level is an aggregate field. And whenever you work with groups and aggregations, you always have this division, okay? You have some fields that you use for grouping, for subdividing your data. And then you have some fields on which you run aggregations. And aggregations, such as, for example, looking at a list of value and taking the maximum value, or the average, or the minimum, and so on. Aggregations are what allow you to understand the differences between groups. So after aggregating, you can say, oh, well, the mages are certainly much more powerful than the hobbits, and so on. And if you work with dashboards like Tableau or other analytical tools, you will see that another way to refer to these terms is by calling the grouping fields dimensions and the aggregate fields measures, okay? So I'm just leaving it here. You can say grouping field and aggregate field, or you can talk about dimensions and measures, and they typically refer to the same type of idea. Now, let's see how I can achieve the same result in SQL. So I will start a new query here, and I want to get data from fantasy.characters. And after I've sourced this table, I want to define my groups. Okay, so I will use group by, which is my new clause. And then here I will have to specify the grouping field. I will have to specify the group that I want to use in order to subdivide the data. And that group is class in this case. After that, I will want to define the columns that I want to see in my result. So I will say select, and first of all I want to see the class, and then I want to see the maximum level within each class. So if I run this, you will see that I get exactly the same result that I have in Google Sheets. So we have seen this before. Max is an aggregation function. It takes a list of values and then compresses them down to a single value, right? Except that before we were running it at the level of the whole table, right? So if I select this query alone and run it, what do you expect to see? I expect to see a single value because it has looked at all the levels in the table and it has simply selected the biggest one. It has reduced all of them to a single value. However, if I run it after defining a group by, then this will run not on the whole table at once, it will run within each group identified by my grouping field and will compute the maximum within that group. And so the result of this will be that I can see the maximum level for each group. Now I'm going to delete this, and I don't need to limit myself to a single aggregation. I can write as many aggregations as I wish. So I will put this down here and I'll actually give it a label so that it makes sense. And then I will write a bunch of other aggregations such as count star, which basically is the number of values within that class. I can also look at the minimum level. I can also look at the average level. So let's run this and make sure that it works. So as you can see, we have our unique values for class as usual. And then for each class, we can compute as many aggregated values as we want. So we have the maximum level, the minimum level, and we didn't give a label to this, so we can call it average level. And then number of values, n values, is not referring to level in itself. It's a more general aggregation, which is simply counting how many examples I have of each class, right? So I know I have 4 mages, 3 archers, 4 hobbits, and 4 warriors by looking at this value over here. And here's another thing. I am absolutely not limited to the level column. As you can see, I also have the experience column, which is also an integer, and the health column, which is a floating point number. So I can get the maximum health and I can get the minimum experience. And it all works all the same. All the aggregations are computed within each class. But one thing I need to be really careful of is the match between the type of aggregation that I want to run and the data type of the field on which I plan to run it. So all of these that we show here, they're number columns, right? Either integers or floats. What would happen if I ran the average aggregation on the name column, which is a string? What do you expect to happen? You can already see that this is an error. Why? No matching signature for aggregate function average for the type string. So it's saying this function does not accept the type string. It accepts integer, float, and all types of number columns. But if you ask me to find the average between a bunch of strings, I have no idea how to do that. So I can add as many aggregations as I want within my grouping, but the aggregations need to make sense. But these expressions can be as complex as I want them to be. So instead of taking the average of the name, which is a string and doesn't make sense, I could actually run another function instead of this, inside of this, which is length. And what I expect this to do is that for each name, it will count how long that name is. And then after I've done all these counts, I can aggregate them I could take the average for them. And what I get back is the average name length within each class. Doesn't sound really helpful as a thing to calculate, but this is just to show you that these expressions can get quite complex. Now, whatever system you're working with, it will have a documentation in some place which lists all the aggregate functions that you have at your disposal. So here is that page for BigQuery, and as you can see, here we have our aggregate functions, and if you go through the list, you will see some of the ones that I've shown you, such as count, max, min, and some others that I haven't shown you in this example, such as sum, so summing up all the values, any value, which simply picks one value. I think it happens at random, and array ag, which actually built a list out of those values, and so on. So when you need to do an analysis, you can start by asking yourself, how do I want to subdivide the data? What are the different groups that I want to find in the data? And then after that, you can ask yourself, what type of aggregations do I need within each group? What do I want to know about each group? And then you can go here and try to find the aggregate function that works best. And once you think you found it, you can go to the documentation for that function and you can read the description. So returns the average of non-null values in an aggregated group. And then you can see what type of argument is supported. For example, average supports any numeric input type, right? So any data type that represents a number, as well as interval, which represents a space of time. Now, in the previous example, we have used a single grouping field, right? So if we go back here, we have our grouping field, which is class, and we only use this one field to subdivide the data. But you can actually use multiple grouping fields. So let's see how that works. What I have here is my items table, and for each item we have an item type and a rarity type. And then for each item we know the power. So what would happen if we wanted to see the average power by item type and rarity combination? One reason we might want to see this is that we might ask ourselves, is within every item type, is it always true that if you go from common to rare to legendary, the power increases? Is this true for all item types or only for certain item types? Let us go and find out. So what I'm going to do now is that I'm going to use two fields to subdivide my data. I'm going to use item type and rarity. And to do this, as a first step, I will sort the data so that it makes it convenient for me. So I will go here and I will say sort range, advanced ranged sorting option. And first of all, I want to sort by column A, which is item type. And then I want to add another sort column, which will be column B. And you can see that my data has been sorted. Next, I'm going to take each unique combination of the values of my two grouping fields, okay? So the first combination is armor common. So I'm going to take this here, and then I'm going to write down all the values that come within this combination. So in this case, we only have one value, which is 40. Next, I have armor legendary. And within this combination, I only have one value, which is 90. Next, I have armor rare. So for armor rare, I actually have two values. So I'm going to write them here. Next, we have potion and common. For this, we actually have 3 values. So I'm going to write them here. So I've gone ahead and I've done it for each combination. And you can see that each unique combination of item type and rarity, I've now copied the relevant values. And now I need to get the average power within these combinations. So I will take the first one, put it over here, and then I will take the average of the values. This is quite easy because there's a single value, so I'll simply write 40. Next, I will take the armor legendary combination, and once again, I have a single value. For armor rare, I have 2 values, so I will actually press equal and write average to call the spreadsheet function, and then select the 2 values in here to compute the average. And here we have it. And I can go on like this, potion common, get the average within these values. Potion legendary is a single value. So I've gone ahead and completed this, and this gives me the result of my query. Here I have all the different combinations for the values of, what were they? Item type and rarity. And within each combination, the average power. So to answer my question, is it that within each item type, the power grows with the level of rarity? Where for armor, it goes from 40 to 74 to 90, so yes. For potion, we don't have a rare potion, but basically it also grows from common to legendary. And in weapon, we have 74, 87, and 98. So I would say yes, within each item type, power grows with the level of rarity. So what are these 3 fields in the context of my grouping? Well, item type is grouping field, and rarity is also a grouping field. And the average power within each group is a aggregate field, right? So I am now using 2 grouping fields to subdivide my data, and then I'm computing this aggregation within those groups. So let us now figure out how to write this in SQL. It's actually quite similar to what we've seen before. We have to take our data from the items table, and then we want to group by, and here I have to list my grouping fields, okay? So as I've said, I have 2 grouping fields. They are item type and rarity. So this defines my groups. And then in the select part, I will want to see my grouping fields. And then within each group, I will want to see the average of power, I believe we used. Yes, so I will get the average of power. And here are our results, just like in the sheets. Now, as a tiny detail, you may notice that power here is colored in blue. And the reason for this is that power is actually a BigQuery function. So if you do power of 2, 3, you should get 8 because it calculates the 2 to the power of 3. So it can be confusing when power is the name of a column because BigQuery might think it's a function. But there's an easy way to remedy this. You can just use backticks. And that's your way of telling BigQuery, hey, don't get confused. This is not the name of a function. This is actually the name of a column. And as you can see, it also works and it doesn't create issues. And just like before, we could add as many aggregations as we wanted. And for example, we could take the sum of power, also on other fields, not just on power. And everything would be computed within the groups defined by the two grouping fields that I have chosen, as expected. Now, let us see where group by fits in the logical order of SQL operations. So, as you know, a SQL query starts with from and join. This is where we source the data. This is where we take the data that we need. And as we learned in the join section, we could either just specify a single table in the from clause, or we could specify a join of two or more tables. Either way, the result is the same. We have assembled the table where our data lives, and we're going to run our pipeline on that data. We're going to run all the next operations on that data. Next, the where clause comes into play, which we can use in order to filter out rows that we don't need. And then finally, our group by executes. So the group by is going to work on the data that we have sourced, minus the rows that we have excluded. And then the group by is going to fundamentally alter the structure of our table. Because as you have seen in our examples, the group by basically compresses down our values or squishes them, as I wrote here, because in the grouping field, you will get a single row for each distinct value. And then in the aggregate field, you will get an aggregate value within each class. Okay, so if I use a group by, it's going to alter the structure of my table. After doing the group by, I can compute my aggregations like you've seen in our examples. So I can compute minimum, maximum, average, sum, count, and all of that. And of course, I need to do this after I have applied my grouping. And after that, after I've computed my aggregations, I can select them, right? So I can choose which columns to see, and this will include the grouping fields and the aggregated fields. We shall see this more in detail in a second. And then finally, there's all the other operations that we have seen in this course. And this is where group by and aggregations fit in our order of SQL operations. Now, I want to show you an error that's extremely common when starting to work with group by. And if you understand this error, I promise you, you will avoid a lot of headaches when solving SQL problems. So I have my items table here again, and you can see the preview on the right. And I have a simple SQL query. Okay, so take the items table, group by item type, and then show me the item type and the average level of power within that item type. So far, so good. But what if I wanted to see what I'm showing you here in the comments? What if I wanted to see each specific item, the name of that item, the type of that item, and then the average power by the type of that item, right? So let's look at the first item, chainmail armor. This is an armor type of item, and we know that the average power for armors is 69.5. So I would like to see this row. And then let's take elven bow. Now, elven bow is a weapon. As you can see here, the average power for weapons is 85.58. And so I would like to see that. Now, stop for a second and think, how might I achieve this? How might I modify my SQL query to achieve this? Oh, and there is an error in the column name over here because I actually wanted to say name. but let's see how to do it in the SQL query. So you might be tempted to simply go to your query and add the name field in order to reproduce what you see here. And if I do this and I run it, you will see that I get an error. Select expression references column name, which is neither grouped nor aggregated. Understanding this error is what I want to achieve now, because it's very important. So can you try to figure out on your own why this query is failing and what exactly this error message means? So I'm going to go back to my spreadsheet and get a copy of my items table. And as you can see, I have copied the query that doesn't work over here. So let us now go ahead and reproduce this query. So I have to take the items table, here it is, and then I have to group by item type. And as you can see, I've already sorted by item type to facilitate our work. And then for each item, we want to select the item type, so that would be armor, and we want to select the average power. So to find that, I can run a spreadsheet function like this. It's called average, and get the power over here. And then I am asked to get the name. So if I take the name for armor and put it here, this is what I have to add. And here you can already see the problem that we are facing. For this particular class, armor, there is a mismatch in the number of rows that each column is providing. Because as an effect of group by item type, now there is only one row in which item type is armor. And as an effect of applying average to power within the armor group, now there is only one row of power corresponding to the armor group. But then when it comes to name, it's neither present in a group by, nor is it present in an aggregate function. And that means that in the case of name, we still have 4 values. 4 values instead of 1. And this mismatch is an issue. SQL cannot accept it because SQL doesn't know how to combine columns which have different numbers of rows. In a way, it's like SQL is telling us, look, you've told me to group the data by item type, and I did. So I found all the rows that correspond to armor. And then you told me to take the average of the power level for those rows, and I did. But then you asked me for name. Now, the item type armor has 4 names in it. What am I supposed to do with them? How am I supposed to combine them? How am I supposed to squish them into a single value? You haven't explained how to do that, so I cannot do it. And this takes us to a fundamental rule of SQL, something I like to call the law of grouping. And the law of grouping is actually quite simple, but essential. It tells you what type of columns you can select after you've run a group by. And there are basically 2 types of columns that you can select after running a group by. One is grouping fields. So those are the columns that appear after the group by clause. Those are the columns you are using to group the data. And 2, aggregations of other fields. Okay, so those are fields that go inside a max function, a min function, a sum function, a count function, and so on. Now, those are the only 2 types of columns that you can select. If you try to select any other column, you will get an error. And the reason you will get an error is illustrated here. After a group by, each value in the grouping fields is repeated exactly once, and then for that value, the aggregation makes sure that there's only one corresponding value in the aggregated field. In this case, there's only one average power number within each item type. However, any other field, if it's not a grouping field and you haven't run an aggregation on it, you're going to get all of its values, and then there's gonna be a mismatch. So the law of grouping is made to prevent this issue. Now, if we go back to our SQL, hopefully you understand now better why this error is happening. And in fact, this error message makes a lot more sense after you've heard about the law of grouping. You are referencing a column, name, which is neither grouped nor aggregated. So how could we change this code so that we can include the column name without triggering an error? Well, we have two options. Either we turn it into a grouping field or we turn it into an aggregation. So let's try turning it into an aggregation. Let's say, for example, that I said min of name. What do you expect would happen in that case? So if I run this, you will see that I have my grouping by item type. I have the average power within each item type. And then I have one name. And so when you run min on a sequence of text values, what it does is that it gives you the first value in alphabetical order. So we are in fact seeing the first name in alphabetical order within each item type. So we've overcome the error, but this field is actually not very useful. We don't really care to see what's the first name in alphabetical order within each type. But at least our aggregation is making sure that there's only one value of name for each item type, and so the golden rule of grouping is respected and we don't get that error anymore. The second alternative is to take name and add it as a grouping field, which simply means putting it after item type in here. Now, what do you expect to happen if I run this query? So these results, as they show here, are a bit misleading because there's actually the name column is hidden. So I will also add it here. And as you can see, I can now refer the name column in select without an aggregation. Why? Because it is a grouping field, okay? And what do we see here in the results? Well, we've seen what happens when you group by multiple columns, that the unique combinations of these columns end up subdividing the data. So in fact, our values for average power are not divided by item type anymore. We don't have the average power for armor, potion, and weapon anymore. We have the average power for an item that's type armor, and it's called chainmail armor. And that is in fact, there's only one row that does that and has power 70. Likewise, we have the average power for any item called Cloak of Invisibility, which is of item type armor. And again, there's only one example of that. So we've overcome our error by adding name as a grouping field, but we have lost the original group division by item type, and we have subdivided the data to the point that it doesn't make sense anymore. So, as you surely have noticed by now, we made the error disappear by including name, but we haven't actually achieved our original objective, which was to show the name of each item, the item type, and then the average power within that item type. Well, To be honest, my original objective was to teach you to spot this error and understand the law of grouping, but now you might rightfully ask, how do I actually achieve this? And the answer, unfortunately, is that you cannot achieve this with GroupBy, not in a direct, simple way. And this is a limitation of GroupBy, which is a very powerful feature, but it doesn't satisfy all the requirements of aggregating data. The good news, however, is that this can be easily achieved with another feature called window functions. Now, window functions are the object of another section of this course, so I'm not going to go into depth now, but I will write the window function for you just to demonstrate that it can be done easily with that feature. So I'm going to go down here and write a new query. I'm going to take the items table and I'm going to select the name and the item type, and then I'm going to get the average of power, and again I'm going to use backticks so BigQuery doesn't get confused with the function that has the same name, and then I'm going to say take the average of power over partition by item type. So this is like saying average of power based on this item type. And I will call this average power by type. And if I select this and run the query, you will see that I get what I need. I have a chainmail armor, it's armor, and the average power for an armor is 69.5. So this is how we can achieve the original objective, unfortunately not with grouping, but with window functions. Now, I want to show you how you can filter on aggregated values after a group by. So what I have here is a basic group by query. Go to the fantasy characters table, group it by class, and then show me the class, and within each class, the average of the experience for all the characters in that class. And you can see the results here. Now, what if I wanted to only keep those classes where the average experience is at least 7,000? How could I go and do that? One instinct you might have is to add a where filter, right? For example, I could say where average experience is greater than or equal to 7,000. And if I run this, I get an error. Unrecognized name, average experience. The where filter doesn't work here. Maybe it's a labeling problem? What if I actually add the logic instead of the label? So what if I say where average of experience is bigger or equal to 7,000? Well, an aggregate function is actually not allowed in the where clause, so this also doesn't work. What's happening here? Now, if we look at the order of SQL operations, we can see that the where clause runs right after sourcing the data. And according to our rules over here, an operation can only use data produced before it and doesn't know about data produced after it. So the where operation cannot have any way of knowing about aggregations which are computed later after it runs and after running the group by. And this is why it is not allowed to use aggregations inside the where filter. Luckily, SQL provides us with a having operation which works just like the where filter, except it works on aggregations. And it works on aggregations because it happens after the group by and after the aggregations. So to summarize, you can source the table and then drop rows before grouping, this is what the where filter is for. And then you can do your grouping and compute your aggregations. And after that, you have another chance to drop rows based on a filter that runs on your aggregations. So let us see how that works in practice. Now, instead of saying where average experience, actually, let me just show you what we had before. This is our actual result, and we want to keep only those rows where average experience is at least 7,000. So after group by, I will write having, and then I will say average experience greater than or equal to 7,000. Let me remove this part here, run the query, and you can see that we get what we need. And you might be thinking, well, why do I have to write down the function again? Can't I just use the label that I've assigned? Well, let's try it and see if it still works. And the answer is that yes, this works in BigQuery. However, you should be aware that BigQuery is an especially user-friendly and fun to use product. In many databases, however, this is actually not allowed, in the sense that the database will not be kind enough to recognize your label in the having operation. Instead, you will have to actually repeat the logic as I am doing now. And this is why I write it like this, because I want you to be aware of this limitation. Another thing that you might not realize immediately is that you can also filter by aggregated columns which you are not selecting. So let's say that I wanted to group by class and get the average experience for each class, but only keep classes with a high enough average level. I am perfectly able to do that. I just have to write having average level greater than or equal to 20. And after I run this, you will see that instead of 4 values, I actually get 3 values. So I've lost 1 value. And average level is not shown in the results, but I can of course show it. And you will realize that out of the values that have stayed, they all respect this condition. They all have at least 20 of average level. So in having, you are free to write filters on aggregated values regardless of the columns that you are selecting. So to summarize once more, you get the data that you need, you drop rows that are not needed, you can then group by if you want, subdivide the data, and then compute aggregations within those groups. If you've done that, you have the option to now filter on the result of those aggregations. And then finally, you can pick which columns you want to see and then apply all the other operations that we have seen in the course.